Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning video brought to you by SQLworkshops.com. In this video, we will take a look at difference in cardinality estimation between table variable and temp table. Let's take a look. To follow this example along with me, you need the SQL test tool. To get the SQL test tool, you can go to sqltest.org website and click on download. There you will see a link to install SQL test. Once you have the SQL test tool, you can go to File, Open Online Examples. There you will find the example SQL test table variable versus temp table estimation. You can press OK to open this example. In this example, we will use a table called tab72. This table has three columns: C1 integer primary key, C2 integer, C3 character 2000. We will insert 10,000 rows into this table. Values for C1 and C2 go from 1 until 10,000. We will create a database called SQL Workshop. If it doesn't exist, let's press OK and let's start the workload 4. To start the workload 4, click on workload 4 and click on Start Current. This will create the table necessary for this example. Let's go to Settings and Comments. Let's copy and paste the select statements into one of our Management Studio windows. Here is our first statement. This statement creates a temporary table called #tab with C1 integer primary key, C2 integer, C3 character 2000. The second statement in this batch is insert into the temporary table, select from tab 72. So we are inserting all the 10,000 rows from tab 72 into this temporary table. And the third statement is we are selecting from this temporary table where C1 less than or equal to 3000. Let's execute this query. Let's have the execution plan on. Let's execute. Let's look at the execution plan. There you see SQL Server is inserting into our temporary table 10,000 rows. And the second statement is our select statement. SQL Server selects from this temporary table. Actual number of rows is 3000. Estimated number of rows is also 3000. If you look at the seek predicate, there you see C1 less than or equal to 3000. So SQL Server estimates 3000 rows. Actual number of rows is also 3000. And SQL Server does a sort. Of course, it has to allocate memory for the sort. And here is the estimated memory for the sort. SQL allocates 8 megabytes. So you see the memory grant, it allocates 8 megabytes of memory for this sort. And the query completes without a sort spill. There is no yellow color, triangle or warning. We will look at it later. So this is our first query, and then we drop this temporary table. Our second batch is we do similar to what we did before, but we use a table variable. So we declare a table variable. We insert the same 10,000 rows into this table variable, and we have a where clause selecting from the table variable C1 less than or equal to 3000. Let's execute this query. Let's go to execution plan. There you see we are inserting 10,000 rows, and here you see SQL Server as a seek predicate less than or equal to 3000. But when you move the cursor here, the actual number of rows is 3000. The estimated number of rows is just 1. Because SQL Server does not have statistics behind the table variable. With temporary table, it has statistics behind the temporary table, so it can estimate using the statistics. With the table variable, since there is no statistics, it cannot guess how many rows will qualify for this predicate. So it estimates 1. Of course, it will allocate memory for sorting this one row because we have an order by C2 here, which needs a sort. So it allocates 1 megabyte. 1 megabyte is the minimum amount of memory every query gets by default. And this memory is not enough to sort all the 3000 rows. That's why there is a yellow color triangle warning that says operator used TempDB to spill data during execution. Since the estimation is not correct, this is because there is no statistics. SQL allocates less memory, and this leads to sort spill. Let's look at another example. The third batch is similar to the second one, except we add option recompile. Let's execute this query. When you add option recompile, SQL will recompile the statement. One advantage is while recompiling, it knows how many rows are in this table variable. So when you go to the execution plan, again we are inserting 10,000 rows into this table variable. But if you look here, the actual amount of rows is 3,000. The estimated number of rows is also 3,000. What happens in this case? Again, SQL Server has no statistics behind this table variable, but since it knows there are 10,000 rows in this table variable, SQL Server guesses, since we have an inequality C1 less than or equal to something, SQL Server guesses 30% of the total rows in the table variable will qualify for this predicate. So 30% of 10,000 is 3,000. So it estimated very good in this case, and there is no sort warning. There is no yellow color warning that says operator spill to TempDB. And when you move on top of the select statement, there you see SQL Server estimated 8 megabyte of memory, or SQL Server allocated 8 megabyte of memory for this query. Let's go to the next example. This is similar to the previous one. We also have option recompile, except we have only 5,000 rows in this table variable. So when you execute this query, SQL Server will estimate 30% because we have an inequality predicate. 30% of 5,000 rows. So 30% of 5,000 is 1,500. So when you go to the execution plan, there you see we inserted 5,000 rows into this table variable. And if you look here, the estimation is 1,500. This is the 30% of 5,000. And of course, the amount of memory SQL Server estimated to sort this 1,500 rows is only 6.5 megabyte. And that amount of memory was not enough to do a sort in memory, so the sort spilled to TempDB. Let's look at one more example here. So this example has option recompile, and it fills in 10,000 rows. The table variable gets 10,000 rows, but we have two inequality predicates. What this means is SQL, while executing this query with option recompile, for the first inequality predicate, it takes the 10,000 rows. It thinks 30% of the rows will qualify for the first inequality predicate, which is 3,000. And then since we have an additional inequality predicate, it will estimate 30% of 30% of this 10,000 rows. So when you execute this query, you go to the execution plan, there you see we inserted 10,000 rows. And if you go to the select statement, there you see it estimated 900 rows. That is the 30% of 30% of 10,000. So the actual number of rows is 801, estimated is 900 rows. So SQL Server in this case did not spill to disk because it estimated more than what is necessary, and it allocated more memory than what is necessary. In this case, 4 megabyte. So you don't have a sort spill. Let's look at the example which is similar to above, the same predicate, except we are inserting only 2,500 rows into the table variable. So 30% of 2,500, and 30% of that will be much less than the 800 rows or 801 rows we are selecting from here. So when I execute this query, when you go to the execution plan, we are here inserting 2,500 rows into this table variable. And if you look here, SQL Server estimated 30% of 2,500, that is 225. The sort spilled, the amount of memory allocated for this query was not enough. It was only 1.4 megabyte. And a final statement here, This is similar to this statement, 2500, except I use a between in SQL Server. It will lead to the same execution plan. For example, if you look here, it says C1 greater than or equal to 1000, less than or equal to 1800. If it's a between, it will lead to the same sort spill. You see the same seek predicate, and then SQL allocates the same amount of memory, 1.4, and the sort spill to this. Let's look at the performance impact of these queries. Let's go to workload 1. In workload 1, I'm executing the select statement, selecting from the temporary table. This is similar to our first batch. We are first inserting 10,000 rows and we are selecting less than or equal to 3000 ordered by C2, and I am executing this statement 10 times in a loop, and this whole batch I am executing 10 times, number of iterations 10. Let's do start current to see how long this takes to execute. This takes 257 milliseconds to execute. If you want to see this time in milliseconds, you can go to tools and click on average DB time in milliseconds. So let's execute again. Let's see. It takes about 280 milliseconds. Let's go to workload 2. Workload 2 is similar to workload 1, except we are using a table variable. We are executing in a loop for 10 times. We are selecting from the table variable, again C1 less than equal to 3000 ordered by C2 10 times, 10 iterations. Start current. There you see the execution time is a little higher because sort spills to disk, and this increases the execution time. Let's start again. You see it is above 300, 350, 360. Let's go to workload 3. In workload 3, we have what we have in workload 2, except we have option recompile added. So SQL Server knows the amount of rows in the table variable, so it can estimate based on the amount of rows. Since we have an inequality predicate, it will estimate 30% of this 10,000 rows. Let's do a start current. There you see it is not taking any more 350 or 360 milliseconds. Instead, it takes only 251 milliseconds. Let's make a summary. Temp table as statistics, this can lead to better estimation and better execution plans. Table variable has no statistics. This can lead to incorrect estimation and possibly non-optimal execution plans. From performance perspective, use temp table instead of table variable if the plan should change based on temporary data which needs statistics. We are not just talking about structure of the plan, also row estimation and memory allocation. If you are planning to change from table variable to temp table in your code, use option recompile with table variable as a temporary workaround to get better estimation until the code change. Inserting into temp table supports parallelism, table variable does not. Take this into consideration when deciding. Concurrent creation of temp table from many sessions can lead to tempdb metadata contention, which can be as worse as tempdb allocation contention. In this case, you may have to use table variable. Thanks for listening. If you have any comments or suggestions, send it to me by email. Bye.